problem, we are considering a swing ride. And what the swing ride consists of is first there is a rotating platform with a radius 4 meters, this rotating platform right here. And for the edges of the rotating platform, we have some cables of length D, and at the end of the cables, we have the seats with mass M. So we're given the radius is 4 meters, the mass of the seat is 10 kilograms, and the length of the cable is 2.5 meters. So, and then when the ride starts spinning, the cables start making an angle with the vertical in the way shown in this drawing right here. So we're given the degree, we're given theta is 28 degrees. So what important to consider is that the circular motion of the mass does not have a radius r. The actual radius of the seat's circular trajectory is given by r plus d sine theta. So just r, this distance here, plus d sine theta, this distance here. So we want to find the speed of the seat. And in order to do that, we just need to consider, okay, let's do the forces on the mass on the horizontal axis and the vertical axis. So on the horizontal axis, you just have this equation right here, where T is just the tension on the wire, given by this, centripetal. It's just a centripetal force. And on the vertical axis, we just have this equation. It's just the weight and the other component of the tension of the cable. So to find the speed, what we're going to do, we're going to take these two equations and divide them by each other. What we do is we get rid of the mass of the turn of the mass, and we get rid of the tension. So we obtain the following relation. From this, we can directly solve for the speed of the seat. It's found to be this square root g r plus d sine theta tangent theta turns out to be 5.19 meters per second. So now what we're going to do is that we're going to put a child, and the child has a mass of 40 kilograms on the seat. So now the total mass of child plus seat is called this big M. It's 50 kilograms. And we need to find, okay, what is the tension on the cable now? So for this, we're going to draw a free body diagram. So the only force factor on the child is the weight of the seat plus the child, which is just big S times C. And then there's the tension of the cable, which makes an angle theta with the vertical. So this cable tension can be broken up into a vertical component, which is d cosine theta, and a horizontal component, which is t sine theta. So to find the tension, we just consider the vertical component of the system, and for that, we just do the force equation of this vertical axis, and find t cosine theta minus mg has to be 0 because it's not accelerating on the vertical axis. From this, we can solve for t, you use big M g over cosine theta, and it gives out a cable tension of 555 newtons.